So the next thing that I wanted to present you is that how I implemented the tests. I call them end-to-end tests. And they are actually can be thought of also as integrational tests. So the thing is that I have, so yeah, so the idea is that I do not want to have unit tests at all in my application. That's because I do not know the structure of the application right now, and this is like the first iterations of the development of the project. So in the first iterations of development project, we need to make an MVP, so that to present to customer as much as quick as possible. And if we go and implement unit tests, it slows down the development because sometimes you want to restructure, you want to change the architecture components to wire them together in another way, or drop down the components into more manageable components. And every time you touch your code, you go and re-implement unit tests from scratch, and for example, drop entirely unit tests and write another one. So this slows down the development, and I think that we should not slow down development in the first stages of development in order to for project to succeed actually. But later, when the architecture is established, the processes are established, and the client actually agrees to continue to work with us, then after that we should cover our application with unit tests as much, like not as much as possible. There is probably some kind of percent, like 80% or 90% of coverage, but yeah, the quality of tests should be also be quite nice. Yeah, but the tests that are always should be written, I think, are end-to-end test and integrational tests to kind of make a snapshot of application functionality, so that you will implement, you will restructure, somehow you will refactor, and those tests will uh, find what was broken, which functionality was edited, if we need to edit this um, functionality, because developer and human and LLM, as of now, they cannot understand the whole system and see all the edge cases. That's why we always need, as we implement, we need to see the coverage of unit tests, and we need to cover more by integrational tests. That's why here, as you can see, I implemented this shell end-to-end integrational tests, but actually it can be thought of end-to-end tests, because we in this test I have this function that I use throughout my tests in order to not duplicate the logic. So what I do is that I reserve the system in and system out, so that to when we run the test, we will set them back to the system, as you can see. So we preserve them and run this print application. It then reads from another. So yeah, we preserved, then we instantiate the captured output, and system set out this captured output so that we can actually read from it in the tests, as well as we system set in, so we kind of mock, so that in tests we do not have the user who writes those commands into terminal, but rather we inject here, you can see script parameter which passed, and every time I have a test, for example, I will pass in the actual, like, simulate the user commands here. As you can see, this variable gets passed to run session function, and then what I do is that I use this script to pass to system set in. And whenever my application gets the input from in system in, it will read this mocked data that I pass. Yeah, and set out I already just described it. We just also mock them. Yeah, so then we run the application and reads from system in, prints to system out, and finally we set back the original input and stream. So this is the pattern that I saw in many applications when I was developing, like when I was a junior developer or intern. We used to create some CLI applications, so this pattern was used. So all of the students, most of the students use this pattern. And the nice thing about Kotlin is that we have so Kotlin has most of the time we have expressions, not statements. It means that constructs return some value. So for example, here we use try, we run the Spring application, and then specify this. This is like return value of this block, okay, which will be assigned to status. So if Spring application runs successfully, then this line also executes and assigns to status, and that's it. Status, we will get the status here when we return the session result. And yeah, right, like that. We, for example, if we run empty input here, we get this session result and see this console output and status. We can later we can assert status, exit status as like that. Cool. Yeah, but if Spring application runs and something like some exception is thrown, we will get to catch block. So not all exceptions, but this intercepted exit intercepted exception. So it means that this application runs and throws this exception, and we just intercept, and the status will be intercepted status. We, from this exception, we see this status passed, and we just return it to status. So the status variable will either be 0 or whichever value comes from intercepted status. Typically the status is not 0 but 1 or other value, which is like mapped to a specific problem within our application. And this finally block is used to, as I said already, to reserve the original system in and out. That's it. And yeah, but the cool thing about that is that my application, as you can see, it actually in production, for example, it does not throw this exit interpreted exception. In my application, as you can see, it uses exit executor, so it will be, here you can see I declared the bin of type exit executor, which is interface. And what does this bin is that it just exits the process. As you can see, this delegates to system exit from Java. And this is not really test friendly. the tests will abrupt, and it has a lot of problems if you test the code which calls this exit process. So what I did is that I declared this bean. You can see this is from config from application, and it will be used in production. But this bean will be instantiated only if we do not have such bean already of type exit executor. Okay. And why I did that is to specifically to have this bean in production, but in integration tests or end-to-end tests, I have here test exit config with this bean also exit executor, but this bean is primary. It means that it will be, this is the first candidate to be instantiated as a bean, and it has not system exit as we saw in previous config for production. As you can see, we have here for production, we have exit process, but in test, I throw this exit intercepted exception, and it kind of hack, but it elegant hack, I think, because it uses interfaces and not a bytecode manipulation or some other dirty hack. So this is elegant solution to to change the functionality within the tests, so that for easier testing, for test friendly execution. So here, as you can see here, I catch this exception, exit intercepted exception, and return status from this exception. It means that whenever we have this exit executor is called within our application, for example, here you can see I have component. This component runs in production, and this component is to handle the exit command. Whenever user inputs exit, it will delegate to exit executor the exit and will pass in the status. But this is interface, and it means that we can do whichever implementation we have. So for test, I have one implementation. For production system, we have another one. So that's basically it. And I would love to see your feedback on that approach, if this is something you would implement in production systems, or maybe you have a better alternative, or you see a crucial problem in it. I would like to hear the feedback, but as of now, I think that this is elegant enough. And thanks for watching.